I'm Scott Hansen. I'm a professor at Southern Utah University, and this module of SolidWorks will include instruction on how to perform a flow analysis using the venturi that was created in the last module. So we'll left click on the open icon, and we'll go down here, and I saved it as assembly 4, and we'll left click on open, and there is the closed venturi. So the first thing we'll do is push the mouse wheel down, and we'll turn it so that it faces something like this. Then we're going to left click on the evaluate tab. First we'll left click on the display style so that we can change it to a wireframe. What's kind of interesting is this is really just a two-dimensional geometry that's made to appear 3D. Obviously you can see this is made up of several ellipses with a portion of an ellipse on the top and on the bottom. So once we get it to wireframe, that gives us access to the inside, because we need to be able to select the inside of the caps to be able to perform the analysis. So we'll move our cursor up to the evaluate tab. We'll left click on evaluate, and then we'll move our cursor over here to the Flow Express Analysis Wizard. We'll left click, and we'll wait for it to load that. Now right here, if you hit the green check mark, it basically just kicks you out of the Flow Wizard, so don't do that. We left click on the little next arrow, and it tells us that the geometry is okay. If you have an error here, you need to go back and make sure your geometry is, you don't have a line over a line or a small gap, and make sure that your lids are matched up to the very ends of the venturi. If you followed the module, the previous module, you shouldn't have any of these problems. We'll left click on the next little arrow again. It says, what are we going to use for the analysis, air or water? Well, we'll use water. So we'll left click on the little left arrow again. This is the flow inlet, and here is the pressure. We'll just go with that default atmospheric pressure, but we need to define which the inlet side is. We'll move our cursor over here to the inside of the model, and if you notice, I'm trying to left click on the inside of the cap, and I'm unable to do so. So right here, I right click and I left click on select other. This little box comes up. As I move the cursor down, it shows me which one of these sketches it'll select. I obviously don't want to select that sketch, and if I move it to the second listing, the inside edge of the cap is highlighted, which is, this is the one I want to select. And obviously if I move it down, now it shows the outside edge of the cap, which I don't want. So I want the inside edge of the cap. So I'm going to left click on that, and these arrows will show up if everything is in order for the evaluation, the analysis. So once the arrows appear, we're good to go. We'll just leave the pressure the same. We'll left click on the next arrow. Now we're going to define the flow outlet. First thing is, if the inlet and outlet pressure are equal, there will not be any flow through this venturi, so we have to drop the outlet pressure. Quick, easy way to do that is just delete this 1. So now we have significantly lower pressure on the outlet side. Now we have to go through the same operation that we did to select the inside of this cap. We push the mouse wheel down until we have access to the cap. It's hard to tell what you're looking at. You just have to remember which way it's really facing. We'll move our cursor over to the cap. You can tell right now that it's not selected. It's trying to select the venturi itself. So I'm going to right click. I'm going to left click on select other. Move my cursor down the list. Here's the inside of the venturi. That looks like the inside of the cap. And that looks like the outside of the cap. So I'm going to left click on the inside of the cap, and we should get some more arrows. I'm going to push the mouse wheel down and turn it back around. And like I say, when it's in wireframe, it's kind of difficult to visualize which way the part is really facing. I'm going to left click on next again, and then I'm going to left click on solve. And depending on how high powered your computer is, this might take a while. I've seen on lower powered computers where this actually will cause the whole program to shut down. No error message or anything. All of a sudden the desktop appears. So it will take a little while for it to crank this out. Like I say, on a faster computer it will solve it fairly quickly. This one seems to be going pretty fast, and we'll just wait here while it crunches these numbers. And what it's going to do is it's going to show us how flow behaves as it travels through this venturi. We've purposely made a venturi so that the air will have to speed up, or water, as it goes through that narrow restricted area. Okay, so we are done with the flow analysis, and there's what it looks like. And so we can left click on the velocity plot, and that will animate it, and that shows what the flow analysis looks like. And then there's a few things we can change. We can stop the animation. We can increase the number of trajectories, and then we can left click on the animate icon again. And right now we're using pipes to illustrate how flow behaves as it goes through this venturi. Obviously the red area means that the speed of the water is increased significantly as it flows through the narrowed area of the venturi. So I'm going to left click on the stop animation command, and we'll left click on the balls icon and then left click on animate, and it shows the balls speeding up and slowing down as they go through that narrowed area. And that concludes this module on how to perform a flow analysis.